Hello, my name is Professor Phil Newton and welcome to this short video in which we're going to talk about the writing of multiple choice questions, MCQs, to assess higher order learning. We're going to focus on this from a formative perspective, the writing of MCQs as a way to help people learn content to a higher level. But everything that we talk about can also be used to write MCQs to assess content at a higher level as well. To do this, we need to talk briefly about what an MCQ is. MCQs are familiar to us all. We take them all the time in quizzes and tests and assessments, and they normally look something like this. There's a question and a series of answer options. To answer the question, you need to simply recall a fact. MCQs have a fairly poor reputation because of this very common presentation of them, factual recall. It's very common to people to think that you can't use MCQs for anything other than factual recall. What we're going to do here repeatedly is show that by adding a problem scenario to the top of an MCQ, the test taker has to solve a problem and then use the answer to that problem to answer the question. That elevates the type of learning that's being assessed. Why do we want to do that? There are a number of practical ways in which MCQs are a helpful way to assess and to learn. They can provide instant feedback. That's really helpful for us when we're learning anything and is also really helpful within certain types of assessment. The writing of MCQs is a really useful learning exercise. The process of writing that problem scenario and then writing the question, then writing the correct answer and the incorrect answer, and then trying to make sure that you're confident about why the right answer is right and the wrong answer is wrong, all of that is a really valuable way of making sure that you fully understand the content. To get the most of that, we need to make sure that we use plausible distractors. This is a technical term. Distractors simply means the incorrect answers, and they need to be plausible. For example, if we write a question where the correct answer is a species of dog, then the incorrect answers need to be other species of canines. This helps us learn to differentiate between content that is similar but distinct as our learning becomes increasingly higher level, as we learn to an increasing level of complexity. Let me give you a simple example. When you're learning neuroanatomy for the first time, you might start by learning what is the brain. Then you might learn what the 4 or 5 major lobes of the brain are. Then you might learn what each subpart of those does, down and down in terms of the size of the parts of the brain, up and up in terms of the levels of complexity. At each stage, what you're doing is taking a whole and then breaking it down into smaller, more specific parts and learning to distinguish between those subparts of something that was previously just one thing. Putting those subparts in as plausible distractors into an MCQ really helps to drive and to reinforce being able to distinguish between things at increasing levels of complexity. This leads us on then to another really important principle, a broader principle in which this video is situated, the idea of retrieval practice. Retrieval is a cognitive process that we all go through when we're trying to make sense of something, including when we're trying to learn something new. When we try and learn something new, we retrieve our prior knowledge of it. That's how we make sense of something. In fact, that's the major part of how we make sense of something, is based upon our prior knowledge. Learning is enhanced if we drive that process of retrieval, if we force the retrieval of our prior knowledge on a subject when we're trying to learn something new about that same subject. One way to drive that process of retrieval is to take MCQ type quiz questions. An even better way to do it is to write your own MCQ type quiz questions. And that's really why we're making this video. That process of going through the writing of MCQs drives retrieval in a way that's really helpful. Retrieval practice is one of the most powerful learning and teaching strategies that we have. MCQs also have some practical benefits. They allow us to cover the curriculum in a much broader way than other types of assessment. Other types of assessment, like say essays and coursework that are used to assess higher order learning, they have benefits in other ways, but they tend to be very narrow in terms of the curriculum that they cover. MCQs are also objective, they're not subjective, and that makes them easy to mark. There's a right answer, and that can be automatically identified by using bubble sheets on paper or by having them marked by a computer. Having an assessment that's easy to mark might not seem like a very valid pedagogical reason to use it, but I think it's really important and I don't want to shy away from it, so I'm putting it up front here. Education is expensive, it takes a lot of resource and it takes a lot of time. And those resources are, in many cases, being squeezed. If we can use an assessment to assess higher order learning in a way that frees up a bit of time for us to do some other things, then that's got to be to everyone's benefit. MCQs are not without their challenges though. They're not perfect in any way. They assess a very specific type of learning. That learning, when it is at a higher level, tends to be the application of knowledge or problem solving, but it doesn't really do the depth that some other types of assessment do. It's also really easy to do MCQs badly. We've all written them, we've all been assessed using them, and because we've seen them in quizzes and on Facebook, then maybe we think we know how to write them, but it's really easy to get that wrong. Now, we're not going to go into the detail of how that is, but I'll give you a link into some common flaws that are found when people write MCQs badly. We're just going to focus here on writing them to a higher level. Now we're just going to get into briefly what higher order learning is. The National Board of Medical Examiners in the US, the people that are responsible for certifying the learning of future doctors, and they classify it very simply. Lower order questions assess the recall of knowledge. Higher order questions assess the application of knowledge, the problem solving that we talked about earlier. This is a slightly more complex example. It's Miller's pyramid. This is commonly used to organise the teaching and assessment of practical skills in medical and health professions education. We start by assessing what it is that people know, and then how do they know it. Then we get them to show us how to do something under controlled conditions, and then they do it in the workplace. MCQs here can get us from knows to knows how. By solving problems, you can demonstrate an understanding that's not possible with simple factual recall. Now, I'm not going to spend a long time trying to persuade you that MCQs can be used to measure higher order learning, because very many people have already done that in a lot of very good studies. The research that we did was simply to take the results of all these studies and synthesize it into a set of practical instructions for how to write those MCQs. What we're going to do here is go through those instructions, just the simple highlights, the most important points to remember when writing MCQs if you want to use them to assess higher order learning. Now, before we do that, I need to just give you 3 points of warning. The first point of warning is really important and relates to a conceptual psychological bias that many of us have. A lot of the research that's been done on whether MCQs can assess higher order learning has involved writing questions and then giving them to human raters and saying, can you determine whether or not this is a lower order question or a higher order question? Is it assessing recall, or is it assessing the application of knowledge and problem solving? Humans, being humans, are subject to all sorts of cognitive biases. What tends to happen when you ask people to rate this is that their ability to recognize a higher order question depends in large part on whether or not they can answer it. Stringer et al. Did this really elegantly. They gave hundreds of questions to some human test takers and they said which one is lower, which one is higher. They gave them some definitions of what lower and higher order learning were. But people tended to say that a question assessed lower order learning if they knew what the answer was, even if it actually assessed higher order learning and vice versa. They would say that a question assesses higher order learning if they didn't know what the answer was. I'm saying this to you because I'm going to show you some examples. Now, I spent a long time trying to write examples that would be accessible to anyone. To write examples that are accessible to anyone, though, you tend to have to know what the answer is. And that tended to mean that people dismissed these questions as being lower order because they knew the answer. So the examples I'm going to use are from neurology and neuroscience because that's my background, and part of the audience for this video are my students who are hopefully writing higher order MCQs as part of their own education. But just bear that in mind when I show you the examples. If you don't know neurology and neuroscience, the question might automatically seem very hard. If you do, they might seem easy. Trust me that the questions in the way that we frame them are going to assess higher order learning, and we'll demonstrate that by contrasting it with questions that assess lower order learning. If you don't know anything about neurology and neuroscience, don't be put off at this stage. The principles should still be very clear, even if you're not completely familiar with what the content of the question is. The second word of warning is that there has been a lot of work on what makes an effective MCQ, the psychometrics, the wording, the formatting, etc. a lot of work on this that's come up with a number, 20 or so different things to look for when making sure that your question is effective. We are not going to go through all of those things. We're just going to cover the main things that are important for helping people write higher order questions. So we're not going to talk about the psychometrics of any type of MCQ or the wording or the formatting, etc. Now, I don't want to ignore these things, though, because they are important, and getting them right can really improve the quality of the questions that you write. But we want to keep this video as short and succinct as we can. So I'm going to briefly show you a checklist that we've written with all of these items on. There's a related warning here, which is that when we teach people how to teach, when we teach them how to give effective lectures and to make educational videos, one of the most important things that we say is do not put lots of text on a slide. It's really distracting. People start to read it and they stop paying attention to you. However, I'm going to show you some slides with lots of text on. This checklist I'm about to show you has a lot of text on it. And then the examples I'm going to show you of the MCQs have a lot of text on as well. MCQs are, by definition, based upon text. The higher order ones have more text in. All right, let me just show you the checklist. You can take a screenshot of it if you want to refer to it. I'll try and put it in the notes underneath the video so you can download a copy of it as well. I'm just going to say that it's there and then we're going to move on, okay? There's no need to read it, folks. Stay with me. Take a screenshot if you want to. I'll put a copy in the download. Okay. Let's move on then to the tips for writing higher order MCQs. I'm just going to focus on the most important things. Start with a lower order MCQ. Start by writing a factual recall question. These are fairly easy to do. Then write a scenario which describes part of the question from that lower order MCQ. So you write a problem scenario. The solution to that problem then links to the answer options in a way that demonstrates and generates a two-step MCQ. I'll explain what this means because these terms are all quite abstract, so I'm just going to show you some examples. The common theme from these examples and from this process is to try and identify what's called assumed knowledge. Something that the test taker knows, but which is not in the question itself. They need to have that knowledge, that understanding, that skill to be able to answer the question though. All right, let me give you an example. Again, this is from neurology. The question is, which part of the brain is most likely damaged in fluent aphasia? Fluent aphasia is a type of language disorder and it results from damage to a particular part of the brain. Therefore, the plausible distractors, and the correct answer are all parts of the brain. And if you're interested, answer option, the correct one is E, Wernicke's area. This is a simple factual recall question. You don't have to understand what these brain regions do or what fluent aphasia is to be able to answer this question. Now we take this question and we elevate the level of it from lower order to higher order. We start by writing a scenario that describes fluent aphasia. So this is what a patient with fluent aphasia might look like. They've had a stroke, that's a common cause of fluent aphasia. The language has changed in the ways that are described. And now we've changed the question. So rather than saying which part of the brain is most likely damaged in fluent aphasia, we say which part of the brain is most likely damaged in this patient. The patient has fluent aphasia, but that is not written in either the stem or the question. That is the assumed knowledge. The stem describes a problem. The problem is, what is the diagnosis for this patient? You have to solve that problem, come up with the answer of fluent aphasia, to be able then to select the correct answer option. This then becomes a type of two-step MCQ. This is just one type of assumed knowledge, and there are many ways that we can identify assumed knowledge for use in this way. The assumed knowledge should be relevant to both the question answer, but should not be in either the question or the answers or the stem when you construct the MCQ. One way to do this is to identify a series of steps needed to solve a problem, and then take out the steps in the middle. For example, the problem might be diagnosis. You might come up with the steps either side of that, i.e. an inspection of the patient or the way in which they present, and then the parts of the brain that are damaged in that patient. The bit in the middle, the actual diagnosis, is the part that we take out and we use as the assumed knowledge. It doesn't have to be a diagnosis. It can be a technical term. It can be a definition. It can be anything that's relevant to your discipline, as long as we've identified a series of steps to get from the scenario to the answer option. Then we take out the parts in the middle, as we take them out of the question, and that becomes the assumed knowledge. We can take this even further. For example, in this case, each part of the brain that was involved in the previous answer options has a particular blood supply. It can be important to understand the blood supply because the patient had a stroke, and localizing where that stroke has happened is an important part of helping a patient recover. So now we don't ask the test taker which parts of the brain are damaged. We ask which branch of the middle cerebral artery was most likely occluded in this patient, i.e. blocked in this patient to cause the damage. Now we have a three-step problem. The test taker has to solve the diagnosis part, then they have to link that to the name, Wernicke's aphasia or fluent aphasia, then they have to link that to the part of the brain that's damaged, Wernicke's area, then they have to identify the blood supply that supplies Wernicke's area. Another way of looking at the construction of multiple step MCQ items, and perhaps the most traditional way of doing it, is that you can, for assessment purposes and maybe also for learning purposes, ask all three steps of the three-step problem and then award 3 marks for it. If you're doing this for learning purposes, you can write out 3 separate questions to give you all 3 steps. This can also help if you're using it for an assessment to give partial credit to those students who maybe only know a part of the learning. For example, in this case, we give the vignette. Then we might ask 3 questions. What's the diagnosis? And then we might ask what part of the brain is damaged. And then we might ask which part of the blood supply to that part of the brain is damaged. Each question builds upon the previous one. To get 3 marks, you would have to have learned this to a higher level than if you just got the first part right. There are some additional things that we can do to help us construct MCQs to assess higher order learning. We can write them in a common language. A lot of our academic disciplines have a particular esoteric jargon, a particular vernacular. By translating that into common everyday language, we elevate the type of learning and understanding that's required to be able to answer the question. Esoteric jargon tends to be a cue, a short circuit to answering an MCQ that we can eliminate by rewriting the question into common language. We can also use active answers, so where the answer options are not like they were in the previous example, a list of different things, or different facts, or different parts of the brain, or whatever it might be. Instead, the answer options are active. Let me give you some examples of these. In medicine, this whole process is fairly straightforward. The stem might be the presentation of a disease, but we might then rewrite it into plain language. Rather than a medical description of a disease, we might write it how the patient would describe their symptoms to a doctor. Simple one-step question would be what would be the most likely diagnosis. Then you can add further steps down the line. What is the next step in forming a diagnosis? That is an active answer. Or what is the next step in the treatment of this patient? Or what is the first line treatment of this patient? Which part of the brain will the first line treatment act on? Which side effects should you warn the patient about? These are not necessarily actions in the sense of taking a physical action, but they are all active. What would you do next? What would you give to the patient? Where would that thing that you give to the patient act? What might be the side effects you would warn the patient about? These final 3 then, these are the higher order questions. The vignette contains the presentation of a disease, but doesn't say what the disease is. In order to answer the question, the test taker has to solve the problem of what the disease is, and then has to know what the first line treatment is for that disease. So there are, again, multiple steps. Previous examples are obviously from medicine, but these principles can be applied in any discipline really. And even within medicine, we can use more than just diagnosing the disease and identifying treatments or anatomy and physiology. For example, an active answer could be a calculation. You might give the test taker a series of numbers. In order to get the correct answer, they have to take a calculation or work with the numbers in some way. You might ask them for an action, as we sort of talked about before. What would be the next step in solving this particular problem? The answer options themselves can also describe an action, like locating something, or increases in something, or voting for something, or purchasing something. These are very abstract ideas, but simply by describing an action in the answer options rather than listing a series of facts, you make the question more likely to be assessing higher order learning. You give a scenario, you give a question, and then you say, what might this result in? Increases in something, decreases in something, etc. To go through multiple examples of these would significantly increase the length of the video, but you get the basic idea. Just make the answer options active. That's really all that there is to it. We've obviously only covered a few simple examples, and they were from neuroscience. The best thing to do really to get a sense of what it's like to write MCQs to assess higher order learning is just to have a go. You can use the checklist I provided on that previous slide to make sure the items are really tight and are correctly and appropriately formatted. But in terms of getting to that problem solving part and that higher order part, just start with simple factual recall, add a problem scenario to it, identify the assumed knowledge that links those two things together, and take the assumed knowledge out of the stem of the question and the answer options. And then you're really most of the way there. If you're a student, and this is really the most valuable part, I think, of this exercise, you can do the exact same thing. That's really the final thing that I want to say. Whether you are an educator or a student, this process can be a really helpful way of delivering retrieval practice. It's a really helpful way of learning. There's a lot that's written about how to design good, effective assessments based on MCQs. There's not as much that's written about how this process can be a helpful learning activity. And that's what this video is designed to help you achieve. So have a go. All right, references are here. And if you've got any questions about the content of this, that's my email address. There is a video about retrieval practice on the YouTube channel, and I'll see you in another video. Bye-bye.